Friends, let's get started. Hello, friends. I'm Ram Lakshmanan. So I'm the architect of GCEC Fast 3D Puro Product Suite. Welcome to our monthly webinar series. In this webinar, we are going to talk about the topic, is your memory correctly sized? I'm doubtful about it, right? So let's get started. Friends, what is the impact of sizing your memory wrongly, right? What is the impact you are going to incur because of wrong memory size? Say, suppose if you're going to under allocate your memory, let's say your application's actual memory, optimal memory size, let's say it is 6 GB. Whereas let us you're under allocated as 2 GB or 4 GB, that is you're under allocated. Then what is the impact? Friends, the primary impact is your response time will degrade. That is, if you're under allocated your memory, then what is the actual optimal size? Then your response time will degrade. So it's going to disappoint your customers. That is because of under allocation. Maybe your response time is, I don't know, 1 second or 2 seconds. But if you are optimally allocated, it would be much lower than that. You would have a much pleasant customer experience. That is the primary downside of memory under allocation. And what is the primary impact of over allocation? So if you're going to, you are allocated more memory than your actual applications demand, then what you'll end up doing is you are going to make already rich cloud providers like AWS, Azure, GCP even more richer, right? Because you'll end up paying more dollars to your cloud hosting providers. So that is a primary impact of over allocating the memory. So friends, in this session, what we're going to discuss is how we are going to come up with the correct memory allocation. What are the strategies? What are the tools? How to come up with the right memory size? Friends, by achieving right memory size, what you are going to do, you are going to improve your customer-facing response time is going to get better, and your cloud hosting bill is also going to come down, right? These are two very significant impacts that you can bring to your organization. It's all a very phenomenal impact that you're going to bring in. So let's jump on. Okay, how to know whether my memory is correctly sized or not? How can I find the answer? Where I need to look to see whether my memory is correctly sized or not? Friend, this is a little bit a tricky question, right? But the answer to that can be found by studying your garbage collection behavior. By studying your application's garbage collection behavior, you would be able to determine whether you have correctly allocated the memory or you're overly allocated, right? You would be able to make the determination. Now, this brings a question, how to do the garbage collection study, how to study my application's garbage collection behavior so that I can find whether I have allocated right memory or not for my application. To do that, friends, to do the garbage collection study, what you want to do is you want to enable the garbage collection logging on your JVMs. The best way to do the garbage collection study is from the garbage collection logs. And the garbage collection logs can be enabled by passing these arguments to your JVM. Say, if you happen to be running on Java 8 or before version, pass this argument and here specify a file path. So when you specify this file path, whenever any garbage collection event runs in your memory, it's going to be logged, it's going to be printed into this file path. And if you happen to be running on Java 9 or above version, use this file path, right? Give this argument so that the GC informations will be printed into this file path. And friends, I would strongly recommend enabling the GC logging on all your production JVMs because enabling it adds almost zero overhead. You wouldn't be able to measure what is the overhead your JVMs are incurring because of enabling the GC log. And here is a white paper published which shows what is the overhead it adds, which is almost zero, right? By enabling the garbage collection log, friends, you can do several wonderful things. Like you can check whether you're going to have performance problems, you're going to have memory problems. You can forecast outages. You can do so many wonderful things, but that is not, we are not going to discuss about that. But having the GC log enabled will facilitate you to a great extent. Okay. So now once you have enabled the GC log is a very tedious and very cryptic file. manually looking into that and trying to get the information from that is going to be very tedious. So for that purpose, you can use any one of these tools which is available in the market. So you can take your GC log and upload it to any one of these tools, and they're going to parse and then they're going to tell you insightful information. I'm not going to be telling you which is the best tool because my opinion is going to be obviously biased. I would say GCEC is the best tool, but it could be a very biased opinion because our company makes it, right? So you can use a tool of your choice. These are some of the available tools. Okay. So I'll just show a demo of how to use this tool, and then we'll start going into the details, right? Okay. So friends, once you have enabled the GC log is going to be a very cryptic file. Let me open a sample file for you to show how does it look like. How does the GC log file looks like? So I'm opening it up. So let's say this is how that file looks. See, this is how it's going to look. It's very cryptic, very unreadable file. But now what you can do, you can take this file and then upload it to one of the tools that I highlighted. So for now, for our demonstration, we will use GCEC. So I can come in here. I'm going to upload a sample GC log file. So once I sign in, what I can do, I can upload a sample GC file. Let me upload a sample GC file. I'm uploading a sample GC log file. Once it's uploaded, it's going to parse, and then it's going to give me all the information. What is the throughput? How does the memory behavior looking? What is the pause duration? All those information it gives. Now, this is how you can do the GC analysis. Equipped with this information, let's keep moving forward, right? Now, let's look at what's going to happen when you're under-allocated your memory. We are coming to the core of the subject right now. How is your GC behavior going to look when your memory is under-allocated? That is, you're allocated less memory than the actual demand is. When you do that, how is your behavior, how is your garbage collection behavior is going to look like? Friends, if you're under-allocated your memory, this is how your garbage collection behavior is going to look like. You can see, just focus here. In fact, here is a live report. Let's go to this live report and then let's look into this. Okay. See what's going to happen. Look at this. You can see when a cluster of red triangle indicates, it means it's a full garbage collection event. Full garbage collection event is running. So this is data for a 24-hour period. It happened on October 5th. For the entire day, it's a 24-hour data. You can see around 12 p.m. Look what has happened. The garbage collection is running repeatedly. Let's just zoom into this one. I'm zooming in. Let's just zoom it more. You can see the red triangle indicates it's a full garbage collection event is running. It is running, but the memory is not coming down at all. You can see it is remaining at the top itself, right? It's remaining at the top. And after a point, it is recovering. After a point, it is coming down, right? For this window, look at this. This is starting around, it is starting around 12 p.m. And the garbage collection is repeatedly running until 12:36 for 35 minutes. It's keep on running. During this window, let's look at what is a pause. See, when a garbage collection event runs, what does the garbage collection event do? It runs and it tries to recover the memory. In order to recover the memory, it stops your JVM. It pauses your JVM. So let's see how much time it is pausing. So here is this pause duration. So look at this graph. You can see a cluster of pauses are happening around this 12 p.m. Let me zoom in here. Okay, I've zoomed in. Look at this, my friends. Let's just take this event. This garbage collection event ran at 12:08. And look, it is taking like 40 seconds to complete. 40 seconds it is taking to complete. But after that, 12:08, let's see, immediately at 12:09, immediately another garbage collection event is getting kicked off. And it is taking 40 seconds to complete. And what does it mean? If it's taking 40 seconds to complete, that means if any customer transaction comes during this time frame, he will not get a response for next 40 seconds. You will not get a response for next 40 seconds. That means the customer response time is going to degrade during this time. What are the transaction that is coming during this 12 p.m. window? They're not going to get a response immediately because garbage collection event is keep on running and it's taking several seconds. During all these several seconds, you're not going to get response. Okay. So why is this happening? Why is this pattern happening? Right? Friends, this is happening because during this time frame, this application is getting more traffic than its regular time window. See, this in the entire this 24 hours window, you can see the memory is very less. But only during this time, the memory consumption is going very high. It is going very high because there's more traffic coming in. Actually, for this application at this time, they were running some kind of a batch jobs. What happens when a batch job runs on your real-time application? When batch job runs, it's going to trigger constant set of transactions. So transaction will keep on coming and hitting. That means more traffic volume to your application. What does more traffic volume translates to? More traffic volume translates to, that means more objects are created in memory. Since more objects are created in memory, now garbage collector is trying to recover that. But since on the other end, traffic just keeps on coming, it's not able to recover. So it's taking more time to complete. So this keeps on continuing. Once the batch job completes, then it drops. Then the memory drops. Then then the transaction starts to resume properly. So friends, when your memory is kind of under allocated, you are going to see this kind of a consecutive full GCs running in your application. It's called as consecutive full GCs. And when this kind of a thing happens, at the very top, the tool displays this warning. It says consecutive full GCs are running. Examine this problem, right? So when your memory is under allocated, you're going to see this kind of a pattern. The GCs are going to keep on running and memory will not be able to recover. And because the GCs are running consecutively, your response time is going to slow down when your memory is under allocated. So this is one pattern number one. Pattern number two is, this is how it's going to look. You can see the request is coming, the memory is building up. And here you can see the red triangles. There is full garbage collection. You must keep on running. And the memory is not dropping. Friends, when this kind of a pattern occurs, it means there is kind of a two possibilities are there when this kind of pattern occurs. This is slightly different from the previous pattern. In the previous pattern, what it is, you can see it is keep on running. After a point, it's able to recover. Once the traffic dies down, then it's able to recover. It's able to drop. Whereas in this case, you can see it is keep on running, but the memory is not dropping at all. So when this happens, it means it can be there could be two kind of possibilities. One is there could be either a memory leak, right? Because when the memory leak is happening, this pattern can happen. Or the second possibility is maybe there is a high influx of traffic coming in, which is creating more objects. How you can differentiate is when you are at this point, what you can do, you can try to remove your JVM from the load balancer. When you try to remove the JVM from the load balancer, then what will happen? Automatically, you're cutting off the traffic. When traffic goes down, if the traffic goes down and if memory drops, it means it's an indication that this problem is happening because of spike in the traffic, not because of memory leak. But if actually there is a memory leak is going on due to some buggy code, then it will not recover. It will just keep on continuing like this, right? So when this kind of when your memory is under allocated, you are going to see this kind of a consecutive full GCs happening in your application. So this is the primary pattern. When your memory is under allocated, you're going to see this consecutive full GCs happen. And when that happens, the GCEC tool flags it as an error for you, right? You're going to see this error reported. Now, I want to walk this through with a real case study. This is a real case study that happened in a very major insurance provider. Let's look at the real data. This is their actual real data. So they got their memory under allocated. That is, they didn't do it on purpose. That as an application has been taking traffic for several years, but the traffic volume has been growing over a period of time. Since the traffic volume was growing, they didn't keep up with increasing the memory or adding new JVM. So this is the actual data. It is a 10 days worth of data. Now let's look at this. You see, it is the tool is warning that the consecutive full GCs are running. Now, let's come here. This is the actual data. Look what this is, a 10 days worth of data. Let's just zoom in to just one particular day. Let's just zoom in on one particular day. I'm just zooming in. Okay, if I say zoom in, I zoomed in on May 6th. You can see the very cluster of red triangles are running. It is starting around, the intensity is starting to pick around 8 a.m. That's when the business is starting, right? The insurance business is starting. At that point, all the agents, the customers are signing in. So the traffic is starting to go high. So the memory is also, consumption is going high. And now after here, around evening time, it's the evening 8, 9 p.m., the traffic is starting to taper off. So since the traffic is tapering off, the memory consumption is also coming down. Okay. See, friends, when this kind of a thing happens, what you're going to see, you're going to see this warning called as a consecutive full GCs. But when this happens, your GC KPI, there's a one of the primary KPI when it comes to GC tuning is called as throughput. See, this throughput percentage is reported as 96.6%. What is this GC throughput, my friends? What does the GC throughput means? So let's look into this. What does GC throughput means? Let's say study that briefly. When someone says, my application is having a 96% throughput, what does it actually mean is, this application is spending 96% of its time in processing the customer transactions. Remaining 4% of time is spent in processing the garbage collection activity. That is 96% is spent in processing the customer transactions, which is needed for running my business. Because garbage collection runs, it stops. It is stopping for 4% of its entire time. Let's say, how many minutes are there in a one day? In one day, there is actually 1,440 minutes are there. That means 4% of 1,440 minutes is 57.6 minutes per day. It means, what does this mean? When this it means this application, when it says 96% throughput, it is stopping your JVM for 57.6 minutes. That is almost 1 hour in one day. This JVM is stopping to do the garbage collection. So if it's stopping for 1 hour, who is paying the price? That means what is going to happen to all the customer transaction that is coming is going to come at that 1 hour window. They are going to experience a degraded response time. They're going to experience a very poor response time. So that's what was happening with this customer. So this customer, what was happening during this peak volume times, during their business window, since the garbage collection is running in the background, constantly running in the background, it is stopping the JVM, their response time was degrading. The customers, the agents were not getting responses. The calls were timing out. If you see the pause duration, let's look at the pause durations. Let's just zoom in here. You can see continuously 2 seconds pause times are continuously happening. If it's continuously pausing, then response time was degrading. So that was the problem that this insurance provider was experiencing. After, when you see this memory under allocation, obvious solution is you want to increase your memory size. So that's what, there are a few more other solutions we'll discuss. But when you see this under allocation, when there's a consecutive full GCs are running, then you want to increase your XMX, you want to increase your heap size. Now let's look at the increased report. Once they increased, look now that consecutive full G, this is the report when the memory is increased. Let's look into the earlier report. In the earlier report, look at this. Their overall size was 9.42 GB. That's what their overall size. Now, when they increased it, they increased it to kind of 13.4 gig. That is, they increased like a 4 gig more. When they increase, look at this, that consecutive full GC problem warning is no longer happening. If you see in the original report, that consecutive full GC warning was happening. Now it is no longer happening. Now, even more, the best part here is, look what has happened to the throughput. The throughput went to 99%. Earlier, what it was? 96%. 96% means it's stopping for 1 hour, almost 1 hour per day per JVM. Now the throughput has gone a lot better. If throughput gets a lot better, that means your response time, your customer-facing response time is going to get a lot better. I want to share with you another interesting case study, one more interesting case study. So this problem happened in a very large automobile manufacturer, They were able to, they had the same consecutive full GC problem. So they were able to, because they were able to address, they were able to improve their response time by 50%. The response time got better by 50%. Think about it, my friends. How many times you, in your career, you are able to improve your overall application response time? That too by 50%. You can achieve if your application is suffering from that memory under allocation. So now let's look into this. This is that report. Look at their throughput, very disastrous throughput. Very disastrous throughput, like a 34% throughput. That means predominant time this application was suffering from this one. But actually, look how much time it is continuously pausing. But actual problem, what was going on in this application was, see, the JVM memory has multiple regions. The JVM memory has multiple regions. There is this heap memory, which is XMX that we set. After this, there is all other memory regions. Sometimes what can happen is you might have allocated enough memory for XMX, but what if you have under-allocated the other region? What if you under-allocate the metaspace? Metaspace is the region where the metadata information required to execute a JVM is stored. That is, say, suppose as a developer, I write a class. As developers, we write customer class, account class, we write. All those class definitions, those metadata definitions are stored in this metaspace. If you're going to under-allocate the metaspace region, then also you're going to run into this consecutive full GC problem. That's what this customer was facing. They had sufficient memory in this XMX, but this metaspace was under-allocated. Since this metaspace was under-allocated, the GCs was kept on running. When those kind of allocations happens also, you're going to see this consecutive full GCs reported. And also it's going to report that there is a, see here, it also raises a warning. There is a problem in metaspace. Address that. It generates this warning, right? Once they address this, the response time went back significantly, right? Went back up significantly. Okay, so now let's just do a quick recap of memory under allocation, what we discussed so far. When your memory is under allocated, the primary degradation is your response time is going to degrade and it's going to cause a very unpleasant customer experience. Number one. What are the symptoms you're going to observe? What are the symptoms you're going to see? Your application is going to become unresponsive. That is because when the garbage collection keep on running, that means customers are not going to get response. That means your application is going to become unresponsive. Sometimes, friends, this may happen. Your health checks will start to fail. If garbage collections keep on running, your health checks will start to fail. If health checks start to fail, it may say your application is unresponsive. It may remove it from the load balancer. Those kind of consequences can happen. And the second thing is your CPU consumption will really spike up because when a garbage collection runs, it's going to consume enormous amount of CPU cycles. So CPU consumption is going to go high when your memory is under allocated. So what are the potential solutions to address a memory under allocation? That is obvious thing is you need to increase heap size. You need to increase your XMX if the contention is happening in your heap. Sometimes the contention may not happen in your heap. Sometimes contention can happen in other memory regions like a metaspace, threads, GC. In those kind of regions also the contention can happen. In that case, you want to increase your region size. Other thing that what you can do can you look at adding more JVM instances, right? Because there is a memory under allocation. What you can do, if you allocate more JVM instance, then your load is going to be distributed to multiple nodes. When load goes to multiple nodes, then the garbage collection is going to ease. So it's not going to put that much memory pressure. That is another alternate way. That is scaling horizontally. Is also another approach to allocate, another solution to handle the memory under allocation. And friends, the fourth option is, can you quarantine this kind of unusual traffic? See, this problem happened because the batch transaction was running. Otherwise, if you're just taking a real-world transactions, no problem. Just because batch was running, it was putting a heavy target, heavy pressure on the JVM. So more objects were created, and the garbage collection was running frequently. Is it possible? Can you run your batch traffic on a separate instance so that it doesn't mingle with the real world? Not only that, sometimes, my friends, what can happen is there are some special transactions. Like, say, I used to work for a bank in the past. So there, certain customers, they come, when they sign in, they have like a 200, 300 accounts with them. Let's say there's a Girl Scout leader. When the Girl Scouts leader signs in, that leader is going to see all their members' accounts when they sign in. So that Girl Scout leader may have like a 250, 300 accounts. So that means when their request comes, we have to go to 300 times to backend system of record and get the data. And then we have to give a response. So it's a very memory intensive operation. Similarly, in your application, there may be some report generation tasks. There may be some transaction which there may be some option for your user to generate some reports. Maybe those reports can trigger a lot of object creation. Is there any way for you to quarantine the traffic to send it to a separate JVMs so that it doesn't meddle with your other real world transaction? Can you quarantine the traffic? That is also another approach to handle the memory under allocation. So this is a quick recap of memory under allocation. Now let's discuss about memory over allocation. That is, what if you have over allocated the memory? Say if your actual demand is only 4 GB, what if you allocated 6 GB or 10 GB? How will the GC pattern will look? How will the GC behavior look when your memory is over allocated? Does anyone want to put anything in the chat? Anyone can guess? Friends, when you have over allocated your memory, your GC behavior will look very normal, right? When you have over allocated, the GC behavior will look very normal. It's not going to show any disturbance. In fact, it will look as if very healthy. Think about it. If your actual demand is only 4 GB, let's say you allocated like a 6 GB or 10 GB, which most of our applications have done, which most of us are doing today. When you over allocated, that means what's going to happen? I kept as 10 GB. That means when request keeps on coming, my memory is going to go all the way till 10 GB and then it's going to come down. Oh, we think, okay, actual demand is 10 GB. No. Since you allocated 10 GB, it's the memory consumption is going till the 10 GB. If you allocate it till 6 GB, the memory consumption will go only till 6 GB and it's going to drop. So your GC behavior is going to start looking very normal. In fact, I would say like this: if your memory looks very healthy, you don't see any problems, there is a very high chance you have over allocated your memory. You over allocated your memory. But what we have done in GCEC is we are doing some mathematical modeling. We have some models. So at real time, we can tell it's not 100% accurate, to a degree. To a degree, we can say you have over allocated. You're going to see this warning reported in your GC report when you upload it to GCEC. We are going to say you have over allocated your memory. In fact, we can say you're over allocated by 47%. Try reducing it and then run the test and see what happens. So here is an example that I want to share, which happened with an actual real security service provider. So this security service provider, they do authentications, right? So they were able to reduce their memory size by 75%. They were able to reduce by 75% because they over allocated. So let's look at their actual memory data. See, this is the actual data of the security service provider. When that happens, we raise this warning. See, your memory has been over allocated. It's allocated by 50% than the actual need. Investigate. So we have that modeling. See here, look at this. Look at the throughput. 99.9%. No problem at all. And look at the pause times. The average pause time is only 218 milliseconds. If your GC behavior looks very, very healthy, then there's a very high chance you've over allocated the memory, right? So what we did, we reduced. See, look at that. They allocated like what 24 gig heap, and the metaspace is 1 GB. You actually don't need this much. So when they reduced, they reduced it by 75%. I think when they gone very low, they didn't see any distortion in their performance characteristics. They didn't see any distortion. Their response time was good. The GC metrics were good. Everything was fantastic. No problem at all, right? So now let me tell sometimes, right? Sometimes the mathematical model, which is there in GCEC, will not accurately detect the issue for you. Here is the reasons for it. Most of the time it will work, but sometimes it may not report it as over allocated. Here is the reason why it cannot tell. Look at this, friends. Sometimes our application may get an interim traffic spike, not a consistent traffic spike. It may get an interim traffic spike. Let's say some batch job runs, say some scheduled job runs. Let's say you're scheduled to run it at midnight, 12 a.m. or 1 a.m. That means that when a scheduled job runs, the memory is going to, when the scheduled job runs, the traffic is going to increase. When traffic increases, the memory consumption is also going to go up. When it goes up, that means the mathematical model will think, it will not be able to think, oh, there is something wrong here. It just thinks a regular traffic pattern. So because of these kind of interim traffic spikes, the model will not be able to detect you properly. And also other thing, for this model to work properly, you need to upload at least 24 hours of when it's a best practice. Whenever you do the GC analysis, you want to upload at least 24 hours of log data. Why 24 hours of log data? It's because in 24 hours, your application will have seen both the high traffic tide and as well as the low traffic tide. So you don't want to make your study just on a peak traffic volume. Or you don't want to make a study when your traffic volume is very low. That means there could be mishappenings could be happening. So you want to be uploading a 24 hours of log data to diagnose it properly. So friends, okay, so now if say suppose you have uploaded a GC log and if the tool is reporting your memory is over allocated, or even if it doesn't report it because of the errors in that, what you can try doing is, if it says very healthy, you can try reducing your memory size. You can try reducing. Now the question becomes how much I can reduce. Friends, you can reduce it as long as these criteria are met. As long as GC throughput percentage doesn't drop or GC pause time doesn't drop, doesn't go bad. More importantly, you can keep on reducing as long as response time, this is the most important, response, as long as response time doesn't degrade, just keep dropping. Say suppose you allocated 12 GB memory size. See what is your response time you're getting. Let's say your response time is 500 milliseconds. Keep reducing from 12 GB heap size, make it as 6 GB and see whether response time is getting hurt. Maybe if response time is not getting hurt, keep moving down. Keep moving down as much as possible until your response time stops degrading. So when you start doing that, you can start reducing your memory size. And friends, when you actually reduce memory size, you are not just reducing the memory size, you are actually bringing down your overall compute capacity, your overall cloud hosting bill. Why is it? Friends, take a look at today, most of us are running in a cloud, or some of you are running in a private data center. As long as a developer we are concerned, there's only 4 computing resources that we deal with. What are those 4 computing resources? CPU, memory, network, and storage. So these are the 4 computing resources. In one EC2 instance, in one AWS EC2 instance, out of these 4 resources, which one gets saturated first? Think about which resource gets saturated first. Then there's always abundant storage. There's always abundant network. Most applications saturates memory first, at least the business applications. They saturate the memory first before a CPU. Just because memory is getting saturated, we are ending up commissioning more and more EC2 instances. On the other hand, there's a lot of memory is wasted because of over allocation. Now, if you can start reducing a memory size of your JVMs, then it means you can run more JVMs within your EC2 instance. That means when you try to run more JVMs in the same EC2 instances, or when you reduce or you can reduce your EC2 instance memory size, automatically your computing cost is going to come down. This is a large wastage a lot of us are making without looking into that. By doing this GC study, if you see, if the tool raises, okay, there is an over allocation, or if it says there's no problem, try reducing it. Try reducing it as long as your GC KPIs don't degrade, a response time doesn't degrade. Then if you reduce your memory size, then we can save significant amount of dollars for enterprise in terms of computing. Okay, so just a quick recap of memory over allocation is, what is the primary impact? The primary impact is we are going to end up paying more dollars to our cloud providers than what is actually needed. Today, a lot of us are doing that. And what is the symptom? The scary part is it does not have any symptom at all. It will look very healthy. It will look very, very healthy. Your GC behavior, your memory, everything looks very healthy. When it looks very healthy, that means there is a very high chance that you're over allocated your memory. And what are the solutions? The solution is reduce your heap size, right? Or you can try cutting down on number of your JVM instances. Or other thing that what I have seen always is, most of the applications have a kind of a flat traffic just for certain time window in a day. That is maybe in the morning when all the customer transactions run at 9 a.m. Or there's some batch job running. There may be some spike going on. Just to accommodate that one spike, which happens once in a day or 2 times in a day, we end up giving a very high heap size. Is it possible? You want to think through, why don't I bring down my memory size? During the traffic, when there's a traffic spurge comes up, at that point, I'll go and scale up my number of JVM instances. And then once the traffic goes down, I'll scale it down. That is that elastic scaling can help you, right? Okay. So friends, that's it. With that, I'm bringing to an end of my talk. I would like to thank everyone for attending this month's webinar. Thank you, everyone. So we will connect back on January with yet another interesting JVM troubleshooting session. Until then, thank you guys. Bye. Have a happy Merry Christmas and have a happy New Year. Thank you, everyone.